0 minutes yesterday to actually work on the assignment.
No, we had 3.
Yeah, 3. That's pretty much nothing. So I'm gonna at least walk you through, or walk you through some of the problems today and give you some time. The section we're in section 10.2 today. This section is based on central angles. Central angles and arc length. It's one of these topics that when you first see it, it can seem confusing, it can seem difficult, especially when you get to the arc length thing. But once you see how to use it, you see the formula is like really short and really simple. It's actually kind of cool what we can use it for, like the actual like purpose of it. So we'll try to do like a ton of like actual like practical use stuff tomorrow in class. So tomorrow will be kind of more like, not really, I shouldn't say hands-on, but it'll be a lot more like experimental, trying some things out, seeing if it works or not. So I'll bring a couple examples and see if it actually does work. So tomorrow will be kind of more of the in-depth day. Today's kind of the shallow, like let's intro what we're talking about. Let's talk about these actual words, like what are they, and the parts of them. Now there's a couple of theorems. We'll probably hit the theorems tomorrow because that's that'll more or less tie into what like the actual work we're going to do tomorrow. But today I want to go through a lot of vocab terms and definitions. So vocabulary. So the first thing, let's go through the first word here, which is the main word here. Let's talk about what a central angle is. Okay, now obviously all this stuff deals with circles because that's the chapter that we're in. We moved into chapter 10, right? So if I draw a circle here, best I can. Call this the center, let's call that A. So the name of that circle, again, according to your homework that you have, that's circle A. That's what we call, that's the name of it, it's called circle A. A central angle is an angle that touches, like the vertex is the actual center of your circle. So in fact, I'm going to write that down. So the central angle has the vertex, so that means like when you draw an angle, the little wedge piece is right on the center, is on the center of the circle. And then the actual rays that make the angle, because when you make angles you have to have 2 rays. The rays are radii of the circle. Okay, so for instance, that's a radius, and that's a radius. Okay, this is the thing we're talking about. It's the actual angle right at the center. That's a central angle. Now you're thinking, okay, fine, that makes sense. You know, it's called the central angle. It's right on the center. There's a huge practical use for that, and that's the thing that I'm going to talk about, like right here, called arc length. Arc length is the actual like distance on a curved path. So let's go through that word. So arc length. Okay, so arc length is the actual distance traveled on a circular path. Circular path. Now it doesn't say like how far you can go. I mean, you can go full circles, like just really whipping around the circle, or you can just travel like a small distance. You don't have to go all the way around. So it could be like start here and you're going to end up over here. That's an arc length. It's like the pizza crust on a pizza. It's the actual distance you traveled. That's something that we can actually calculate. It's an actual like super easy formula for how they actually come up with it. The problem is it uses a couple things that we haven't really discussed yet, and I'm going to kind of wait probably till tomorrow to actually talk about it. But I'll just give you the hint what it uses. So to find this length, this is the arc length itself. An arc is the actual like curve on a circle, the path. To find that arc, like how long it actually is, you use this angle, that central angle. So we're going to use this angle, and we're going to use the length of the radius. So, because I said, the radius is the most important number in a circle. If you have a radius, you can pretty much find everything about it. You can find, diameter, obviously. You can find circumference, that's the distance all the way around. You can find small lengths, like that arc there. You can find the area of the circle, that's how many like little square tiles you can fit in the circle itself. And that was something we kind of touched on yesterday. But this is what we're going to be going into tomorrow. We're going to try to do some like hands-on examples of how that works. Make sense? Okay. But that's the intro, right? There's a couple words that go with this idea of like the central angle. We're not going to talk about arc length until tomorrow, but the actual central angle itself and the angle measure has 3 terms I want to talk about. So angle measure or arc measure. Okay, so the 3 angles I want to discuss. Number 1, called a minor arc. We'll talk about like how the angle measure applies to that and what the word minor arc means. We're going to talk about a semicircle. Most people know what a semicircle is, but it actually has a weird definition here. And a major arc. These are the 3 terms I want to talk about today. Once we're through those, that's when we're done today. And then I'll just do a couple examples of your homework. Make sense? So we're not taking very many notes today. All right, let's jump right in. Obviously, we know what angles are, right? Angle measures and how we open up. But I want to talk about like what a minor arc is, a major arc for this like picture that we're using here. So let me get rid of these objects here. All right. Okay, a minor arc. That is the short distance between 2 points on the circle. So here's A and B. So what a minor arc is, and let me get rid of some of these words here. That's terrible. Tablet. That's all right. And this will do. Okay. So minor arc. A minor arc is the shortest distance between any 2 points on a circle. That's what the book says. Is the shortest distance between 2 points on a circle. Now, there's a secondary part to this. It is actually traveling along the circle. Now this is huge. In fact, I'm going to put a little star next to that. That's big. We're actually traveling along the circle path. I'm not cutting through the middle. Because actually the shortest distance between the 2 points on a circle would be like a line going straight down, like not even going along the circle. I'm talking about we're traveling the path of the circle, the actual curvature of the actual like rotation here. This is called a minor arc. Now, how we actually name it, like how you actually write that down, like the notation for a minor arc, this is the part that people get wrong all the time, the actual notation. Notation for minor arc, you write the 2 letters down, actually use these letters, you write the 2 letters down of the actual dots that you're hitting. You write A and B, and if there's any more dots in there, it doesn't matter, just use the 2 that you're going through. And then you put a little bubble up above it, like a little hat, like a little cap on it. That is called a minor arc. It's 2 letters, it's the smallest distance between two points on a circle. Now, there's things that can represent this. Obviously tomorrow we're going to talk about like how to find the actual like length, the distance. But what we describe in geometry class is we can describe minor arcs by the angle at the center. So the central angle here that's actually looking at that arc, that's how we describe it. So what they do is if they put a little M out front, that means they want the central angle measured. So that's a little weird notation. But the N means that the actual angle. So if I made up this angle, let's say this is, I don't know, 50 degrees, right here in the middle of that circle, right here at the center, that's 50 degrees. That's this number here. That's how you describe minor arcs. If you leave the little m off of it, we're actually talking about the distance itself, which is a little weird. I know that seems off, but the measure of it is actually the central angle measure. All right, questions with what a minor arc is? Now you can have multiple minor arcs in a picture, like they're just small distances, but you just pick 2 dots and go between them. Now, it's the shortest distance, so at some point, what they're trying to describe here is that you could go the long way around. Like, I could go this direction and get to B. Because technically that would still get me there, it's the long distance. That has a different name, obviously. That name is called a major arc. So, let's change here. So the major arc is the longest distance. The longest distance going to 2 points on a circle, and it's traveling along that circular path. Now the problem with the notation is that we need 3 letters. You can't use 2. 2 is always the shortest path, so when they go the longest path, they try to use the biggest distance possible, so they'll use multiple points down the road. So, you know, here's A and I'm going towards B. Maybe there's like a C down the road over here somewhere. Doesn't really matter where it's at. There's a C. When you name the major arc, you actually use the letter you started at, the next letter you hit, and then the last letter. And then you put a big arc above it. That's the notation for a major arc. That's how you know if like you're going the long way around or the short way, whether using 2 letters or 3. Now, here's my question. If I put a little M out front, I want the measure of it, right? The central angle for the major arc. What would the measure be of the long way around? You don't happen to know? You don't happen to know the long way around? Because the short path is 50 degrees. 310, yeah. The large arc is actually 310 degrees. Now, how do you know that? You're correct. Yeah. One full circle, like a circular path, is 360. So the idea is that if you're going all the way around, it's 360. Well, we didn't go all the way around. We went 50 short of that. So the whole circle is 360, and then you subtract 50. Okay. So you get 310. We're good? All right. So that's the idea. So just remember, the full circle is 360, and we're going the other way around, so we're not using 50. So that's the idea. Now, obviously, tomorrow when we start looking at arc length, the actual path, like the actual distance, we can use that fact, that 310, to help us find that out. So, questions, comments about the 2 words? Last word today, semicircle. Okay, in fact, where do I want to put it? Get rid of the arc here. We'll just put it right here. All right, semicircle. Okay, semicircle is when you write it down like the notation, it's considered a major arc. But a semicircle is anytime you're doing an actual arc, when you're actually drawing an arc and the endpoints are the endpoints of the diameter. So what I mean by that, so if you're drawing an arc on a circle, let's go back to this picture. Let's leave C there. So here's my diameter, let's call this D here. So that's a diameter, it's going straight across the circle, passing through the middle, that's what a diameter is. A semicircle is the actual arc path using those endpoints that are on the actual diameter itself, so A and D. Now, when you write it down, the notation of it for an actual like semicircle, you still have to use this. You still have to use the major arc because it's not the shortest path. It's almost to the point where it's just less. It's almost just a minor arc because minor arc is the shortest distance, but it's like that middle between a major and a minor. So that's why they call it a semicircle. It's because it's perfectly like 180 degrees because it's half of a circle perfectly. So they still consider it a major arc. So when you go around, it doesn't matter which way you go, it's still the same distance. You have to use 3 letters. So you could say it's A, C, D. It could be that, or it could be the other way around, which is A, B. those are the same thing, because if it's a true semicircle, this actual path is the same distance. Now, if you put little ends out front, I just already said what the measure is. What's half of the circle? Yeah, 180. They're both 180s. Now, when you spin like halfway around, it's 180 degrees. That's the idea. But that's a semicircle. It's an arc whose endpoint's the actual diameter. It's half of the circle. That's the best way I can say it. But you have to use 3 letters. That's how I know if I'm using like short. The best way I always describe arcs to people, if it's a minor arc, it's anything that's less than a straight angle. So like 150, 60 degrees, 20 degrees, 90 degrees. Those are all minor arcs. But anything more than 180 is a major arc. So you have to use 3 letters. All right, questions, comments about any of this stuff we've talked about today? Okay, again, we're gonna really do like more hands-on stuff today. So we'll talk about, how to find the actual distances and all that good stuff. All right, here we go. Let's talk about some of the actual homework now. All right, so the actual homework problems that you have. Let me get rid of this stuff. Again, we'll come back to this stuff tomorrow. We have, I think, 2 theorems we're gonna have tomorrow, 2 properties. One's a postulate actually, but one's an actual theorem. All right, so one of the homework problems that you have in your book that you're gonna have to do, obviously, is name objects on circles. So don't be afraid of that. One of the examples I kept showing you the last couple days. Let's call this N. We can put points up here. Let's go G, F. Let's go N, Q, P, and W. All right, so we got some different letters here. W to G is going straight across. All right, and let's go this one. All right. Okay, so what I want here is the name of this circle. Yeah, so circle N. So that's how you write it in your book, or you can draw like the mock picture and then put an M behind it. These are the same thing to me. A radius, a radii. Say it again. MG, okay. MQ. MP. What is it? We have one more? MW, or WN. Doesn't really matter the order. You don't even need to put the bars above it. So if you go WN, you can just leave it like that. It's totally fine. 2 letters only. Those are most of the homework. Diameter. Running straight across. WG, yeah. So WG, you can leave the bar off it. You can put it on only 2 letters. Don't use all 3. Don't say WMG. That's not what I want. 2 letters only. Chord. Chord. Say it again. NF. Okay. NF. And there's one more. GW. Yeah. Even though WG or GW is a diameter, it's still considered a chord. Remember, the definition of a chord, it goes all the way across the circle, has the 2 endpoints on the circle itself. So those are terms, I think that's like a majority of your homework. Now there's a couple problems, yeah, there's a couple of them where they have you calculate like circumference, the distance around. So all you need for those is you just need to find the radius. If you have this radius number, let's say it's 5 inches, you can use that number to find the circumference, the distance around the circle. So the formula for that, remember, is 2 times pi times r. And when you actually do that, I can show you the exact answer and then I can show you a decimal. If you're going to do the decimal, I just used the first couple decimal places on pi, and that's on the board up here if you don't know. Most calculators have the pi button, but the exact answer, so if you plug in the 5, right, 5 inches, and we're going to multiply these 3 numbers together, the exact number is 10 pi inches. That's where they don't actually multiply pi, they just take 2 times 5, and that's what they leave it as. That's the exact answer. But most people would actually take 10 times 3.14. And this would be the decimal approximation of it. So if I multiply this by 10, I get 31.4 inches. And that's the circumference. This is the distance all the way around your circle. So it's 31 inches. That's what, 2 feet and some 2.5 feet, roughly? Okay. All the way around. So it's kind of a large circle. that's a majority of your homework. Now, if they ever give you circumference, they give you this number, then fine. You divide by 2, divide by pi, and you have the radius. Now you have the r. So you can solve it backwards. I think that's a majority of your homework. There's that goofy problem I showed you yesterday where they had like 3 circles overlapping each other. Let's see. What was that? Let's see if I can think about the letters. It was like A, B, and C, and there was an F and a G, but it was something like this, if I remember right. Terrible circles. Alright. And it was something like that. Let's just make this one big circle there. There you go. Okay. It was something like this, where this is A, this is B, this is C and D, and these points I don't even know. Let's go E and F. Alright. And this circle actually, like the circle C, actually passed right through A. Sorry, it's a terrible drawing. But what they say in the instructions is like the radius or diameter, it doesn't really matter. Let's just say the radii. The radius of circle A is 10 feet. The radius of circle B, or C I should say, circle C is 30 feet. And D is 5 feet. So that's a smaller circle. Okay, so if those are your numbers, you can actually find the certain lengths that are on these things. So like one of the questions I know they ask is like, what is that length right there? It's not drawn to scale by any means, but how you actually find it. Knowing that the radius of circle A is 10, this is 10 feet, going from A to B, because that's the radius, that's what the definition of radius is. Then you can find BC, because this whole radius they just told me a little bit ago was 30. This whole, like, from C out was 30, that's the radius. That means this has to be 20, if you think about it, because 20 and 10 make 30. So that was the type of question that they ask. The problem is I couldn't actually find these pieces unless they give me those, like one of them at least. Because I know the full radius of circle C and I know the full radius of circle D. Problem is I can't find those little individual pieces unless they told me one of them. Because it's not like this side where it perfectly went through A. Like this went kind of in the middle between E and D. So it's not going to work out pretty unless they tell you, like in the instructions, one of them is a certain number. All right, questions, comments about that style of problem? Okay, homework's on the board. That's your page 701. Make sure you're working on that. It's due tomorrow unless you weren't here the other day. Then you can work on that. But again, page 701, I'll put it up here. 1 through 6. What do we got? 10 through 15. And 25, or 18 through 25. There you go. Yeah, due tomorrow. Make sure you're working on it. You have the rest of the time today, which is about 15 minutes, 16 minutes. Kind of work. About what I wanted. All right, there you go. Yeah.